Let's go through LeetCode 298, binary tree longest consecutive sequence. And this question gives us a binary tree, return the length of the longest consecutive sequence path. It says that a consecutive sequence path is a path where the value is increased by one along the path. And note that path can start at any node in the tree, and it cannot go from a node to its parents in the path. That means take this example, it can only from a node to its child. It can increase by one, and you'll see, so this one, the path will be 3 because there are 3 nodes included. If there is a 7, yeah, you can end also at any nodes. And for this question, what we're thinking about is that we can use up some kind of post-order traversal. That is, for example, if we have a tree, which is a node, and for its left child, and it has left child and right child, and if it's left child, we already calculate, for example, the longest consecutive sequence path, which end or which we'll say which we start with, or whatever, we start with this left child. For example, if we start this node, we have a length, for example, that is 3, right? And if we then we try to see whether this number, this value is one greater than this value, right? If it is 1 greater, then we can have the longest consecutive path end with this, start with this node, or be trying to see whether it can be updated. This one plus 1. Also, we calculated right path, right child, trying to see the longest consecutive path end with the right node. What's the longest one? And if it is also this v right is equals to v plus 1, we are trying to see whether we can update this one to be this kind of longest path 1. And so actually we're comparing these two. If we cannot, for example, this value cannot connect to its both child, right? Then we just have this one update to 1. We do post order traversal, so that every node we calculate it's the longest consecutive path. We start with this node, and pass this value to its parents. And every time until we finish the traversal, right? Every time we have a node's longest, we have a maximal global variable, trying to update the maximal global variable. So let's begin to write code. If we don't want to have the global variable, we can use a result to update, to pass in this integer array, right? And we want to have DFS result, and return result 0. So this is the same as a global variable. If you can also define the max outside. So for this kind of, we are going to have a DFS. We are going to return an integer. And the result, right? The definition of what this return is that the longest path start with this node. What is the longest path length? So let's say if this node equals null, return 0. And then we have int left length equals DFS node left result. And int right length equals DFS node right result. Let's say int length. For this node, it will at least include itself, right? So it will be 1. If L length, if this one is greater than 0, right? And also node dot left. If this is greater than 0, means it's a left child is not null. Dot value equals node value plus 1. Then we'll have length a length plus 1, right? And let's say if right length greater than 0, and node dot right dot value equals node dot value plus 1. That means we can connect to the right, right? Then length equals max dot max length right length plus 1. And here, every time we calculate length, we are trying to see if this length is greater than result 0 or not. We compare with the global variable. If this is greater than result 0 equals length and return length. Okay, so do this way, every node we just calculate once time complexity will be O(n) time complexity. If you DFS, there is n times the recursion call. So we can call it O(n) space complexity as well.